We are going to look at how to verify, to tell if any two functions that someone gives us are actually inverses of one another. And we're going to do that by using our composition, just like we were doing in the last couple of lessons. We're going to do f, the original function, composed with g, and then we'll also have to do g composed with f. Both of those problems have to give us an answer of x, nothing else, just one x. If both of them don't come out to be x, then they are not inverses. All right? So we're going to do f of g of x, which is the x squared plus 3. So I'm plugging x squared plus 3 all into the f equation. So I'm going to get square root, and I called it an equation. It's really just a function. In this case, it's an expression. In place of the x, I'm putting the x squared plus 3. That whole piece represents the x. Then I also need the minus 3. So I'm going to combine my like terms underneath the radical, because there is no multiplication going on. Subtraction would be the higher operation there. So I will wind up with x squared, because these two will cancel out. 3 minus 3 is 0. This is a positive square root. The square root was there. I didn't introduce it in order to get rid of a square. The square root was just there in the equation. So I take the sign based on what's in front of it. There's nothing, so it's an understood positive. The radical cancels with the square then to leave me just a positive x. There's no absolute value, just positive x. So then I'm going to do the same thing, but in reverse. I'll do g of, and plug in my root x minus 3. That is the f of x, and it becomes my x in the g of x equation. So the thing that's being squared is that root x minus 3 plus 3 added at the end. So I square that. It's given as a positive, so we get just x minus 3. Bring down our positive 3. Those will cancel, so I get an x. Because I get x for both, I know f of x is the inverse of g of x, or they are inverses of one another. So we really shouldn't say one is the inverse of the other, but f of x and g of x are inverses. Right? F of x and g of x are inverses. Alright, so some of the problems, actually the rest of the problems we're going to look at, are going to give us a function, and they're going to ask us to graph it, tell if it's a function, find its domain and range, then find the inverse of that, tell if it's a function, domain and range, and then verify. Okay? We're not going to do the verification on all of them, just as a matter of time, but we'll work through a couple of those. For this second equation, or second problem they've given us, this is my function. I know that's a line. It has a y-intercept of 7, slope of 2. So it looks something like that. So here's my original function. Does that pass the vertical line test? Sure. It is indeed a function then, because it passes the vertical line test. A line always has a domain of all real numbers, negative infinity to positive infinity. It also has a range, because it goes all the way down, all the way up, a range of all real numbers. Here's one thing that we know. If these are going to be inverses, these two values should switch. So this domain should come down to be the range here. This range should go up to be the domain here. Right? So to find my actual inverse, I'm supposed to take this y value, remember f of x is the y, and switch places with the x. I'll get x equals 2. I'm going to use the inverse symbol now, though, to show that I know I switched places. So that will give me x minus 7 equals 2y. And then I'll divide both sides by 2, so I'll get x minus 7 all over 2 equals y inverse. Since I want to graph that, I'm going to write that as two separate fractions, and I'm going to say that's x over 2, or 1/2 x, minus 7 over 2, or 3.5. So 3.5 negative 3.5 is going to be my y-intercept. So 3.5, and my slope is 1/2, positive 1/2. So I'm going up a block over 2. Up a block over 2. As such, and we can do a little bit in reverse. So I get something that looks like this. Okay. Again, it is a line, so we know its domain is all real, as is its range. The orange, is that function? Sure, it passes the vertical line test, so of course it is. To verify, I'm going to do f of g of x, which is I'm leaving it in this form here, x minus 7 quantity squared. That's the inverse. So when I plug it into the f equation, I'll get 2 times x minus 7 all over 2 plus 7. The 2's cancel, so I get x minus 7 plus 7, which also cancels. I get an x. Then I have to do the other route. I have to do y inverse. So on the top, in place of the x, I'm putting all of the f, 2x plus 7. So I'll get 2x plus 7, that's the x, minus 7, all over 2. Combine your like terms, because you always have to clean up the top or the bottom of the fraction first. So those go. I get 2x over 2, which leaves me just x. They are inverses. Alright, so take a look at the next one. We are going to identify that is a parabola. Its vertex should be at 0, 5. It does not stretch or compress, and it opens up. So, looks something like that. There's my axis of symmetry. That's going to open there, and there. That looks good. Is a parabola a function? Does it pass the vertical line test? Yes. Is it, what is the domain of any parabola? Well, that's all reals. It goes all the way to the left, all the way to the right. My range is going to be from 5 to infinity, or y is greater than or equal to 5. The inverse of that should then have 5 to infinity, or your domain, and all reals for your inverse. So we'll use that kind of as a check. It doesn't verify. It tells me nothing official, but we'll use that as a check for us. So again, here's our y. So when we switch those two, I will get x equals y squared plus 5. So subtract your 5. It's y squared. Take the square root, and that winds up giving you square root of x minus 5 equals absolute value of y. We've got absolute value, we need that piecewise. So y, if y is greater than or equal to 0, and opposite of y, negative y, if y is less than 0. So I will get y equals root x minus 5. I'll also get negative y equals root x minus 5, which means y equals the negative root x minus 5 as well. So our inverse is actually going to be both of those pieces, the positive and the negative. So I'm going to put them together as plus or minus x minus 5. That's what I need to graph. That is a square root graph, which we were doing lately. That graph goes 5 to the right, does not go up or down. My parent function, because there is no stretch or compression or reflections here, I'll go 1 over, 1 up. I'll go 4 over, 2 up. The square root of 4 is 2. This is my positive side. Then I do need to do the negative, which is the reflection of this. I'll have this portion here. And does that have a domain from 5 to infinity? Sure. Does that have a range that goes all the way down, all the way up? Sure it does. It opens down, it opens up. Okay. Does that pass the vertical line test? Hopefully you're telling me no, and then that means that it is not a function. Alright, looking at the next one pretty quick. By the way, we did not verify that one officially. We will do another one. Looking at the next, I'm going to graph that to 5. 1, 2, 3, 4, 5. And it's a parabola. So, looks something like that. Yes, it's a function. Its domain is all reals. Its range is also 5 to infinity, which means my domain should also be 5 to infinity, and my range should be all reals. I am going to simply take a quick second and just go through and find that inverse. That's going to be, we would go through those steps, but that would wind up giving me an inverse of plus or minus square root x minus 5 plus 2. Right? If you need to see the steps on that, you can stop the video. I'm going to put my work under here, and we will graph that. So you can take just a second. There are your steps. Stop the video. And then we will go about graphing this one. Alright, so the graph looks like this. And the question is here on the bottom. Sorry. It is not a function. It would fail the vertical line test. The question at the bottom of the page asks, what do you notice about the graphs? Hopefully you're noticing that there's a reflection there. It's just not a reflection over the x or the y. It actually reflects over, so you can see it, reflects over this line, y equals x. This line, y equals x. And again on the third one, it reflects over that line, y equals x. You can draw that line in if you'd like. It would go through the origin, have a slope of 1. I'd leave it as a dashed line if you're going to draw it in. But that is what an inverse should do. It should reflect over y equals x line. Alright, last problem. They've given us a parabola, but it is not in vertex form, so practice completing the square on this one and see if you can put it in vertex form. That should be f of x is going to be a x minus 2 squared plus 3. When we calculate the inverse of this should be plus and minus root x minus 3 plus 2 on the outside, right? Okay, so function f is the green one, and the inverse is the orange. No, the orange is not going to be a function. The green will, and our domain and range are given. And we want to know, does every function have an inverse function? Answer the question, let me know what you think. And I'd like you to try the last one on this page by yourself. See what you can do with f of x equals x squared. We'll pick up with that in class and go over that. And maybe read through the next question, which is simply, how can we tell if a function will have an inverse? See what thoughts you have about that.